Hello everyone and welcome to my channel. In a recent video, I shared how I saved a lot of money on a sim racing seat by buying secondhand on Facebook Marketplace. Unfortunately, used parts are rarely perfect and my GT Lite racing seat was no exception. I'm going to show you how I use 3D printing to fix my sim racing seat, and by the end of this series, you'll have the tools you need to get started on your own 3D project. After bringing my GT Lite home, I fired up Assetto Corsa Rally, only to find that my steering wheel was tilting down as I was racing. After doing some research online, I found a Reddit post where someone was experiencing the same thing. They pointed out that they realized that they had forgotten to put a lock washer on the back of their steering wheel. That's when I realized that I was missing that washer too. I decided to take my sim racing seat apart so that I can make my own. I started by taking off the bolts that hold the steering wheel to the base plate. Next, I took off the 4 bolts that hold the base plate to the rest of the seat. Lastly, I removed the plastic grooved piece where the washer is supposed to bite into. Clearly the washer's been missing for a while and you can see the teeth have worn off. Next, I started to get the dimensions that I needed to model my new lock washer. The spacing of the teeth, the length of the washer, the diameter of the front bar, the outer diameter of the lock knob, the outer diameter of the front weld bolt, the thickness of the black grooved piece, and the height of the teeth. And lastly, the length of the weld bolt. After getting the measured dimensions, I used a simple diagram to calculate anything that was missing and to make it easier to picture the model that I needed to make. I used Fusion 360 to do the 3D modeling. You can use Fusion 360 for free by downloading the hobby version and making an Autodesk account. I'll post a link in the description. I also used Prusa Slicer to make my G-code for the 3D printer. This is also free to download and use, and I'll include the link to this as well. You can get started in Fusion 360 by going to File, New, select Part Design, make sure that millimeters is selected, and create New. The first thing I did for my part was make a sketch. Then I made a vertical line by selecting the line feature on the top left. I then turned it into a construction line for reference by right-clicking on the line and selecting Normal/Construction. Next, I made a bottom line. I made it coincidence to the origin by selecting a line in the origin point while holding Control and selecting Coincidence and Constraints. I repeated this with the vertical construction line. Then I dimensioned my bottom line to be 25mm, which is roughly how wide I want my part to be, which you can do by holding D while selecting the line. I then centered my bottom line by dimensioning the endpoint to my center construction line and entering half of 25mm. Next, I used the circle feature on the top left to make a circle that's in line with the center construction line. For my circle dimension, I have the 25mm from my front bar, plus the 8mm from the thickness of the black grooved piece, plus 1.2mm for the height of the teeth. I then multiplied all this by 2 to get the diameter. I then went to Create and selected the point feature, and made a point at the bottom of the circle. Next, I used that point to dimension the gap between the circle and the bottom line, which makes up the thickness of the part. I followed that up by making an additional concentric circle that makes up the points of the teeth. Again, the height of the teeth is about 1.2 mil. Then I made a couple of outer lines to make the sides of my part. Now that I had my basic shape, I made points 2mm apart to match the inner grooves of the teeth. Then I made points for the peaks of the teeth. Lastly, I made lines to connect all these points to make the right side of my teeth. I then selected both sides of each tooth and used the equal feature in the constraints to make all the teeth identical. In order to save time, I reselected all the lines and clicked the symmetry feature on the top left. For the mirror line, I used the center construction line that I had made before. I then exited the sketch. Next, I clicked on the extrude feature on the top left and selected the base of my part and all the teeth. I entered 33mm for the length of my part and hit OK. At this point, you can see that the part's just missing the hole in the center. So I rotated the part to make a sketch on the flat side. Again, I made a center construction line that was coincident with the origin for reference. I then made a circle that was 10mm in diameter, which is a little bit larger than the diameter of the weld bolt. I dimensioned the center of the circle to be half of 33mm, which is half the length of this part. Next, I made a point underneath the circle on the center construction line. I connected two lines to the circle, made them equal to each other, and made them tangent to the circle. I then dimensioned them to be 90 degrees apart. Next, I made a horizontal line and a point at the bottom of the circle, and dimensioned these to be 0.6mm apart. I'll explain why I did this in a bit, but for now I'll just call it the water drop feature. I then exited the sketch. Next, I used extrude again. However, this time I used the cut operation and selected the circle so I could remove the bolt opening from the part. And now you can see our first model is complete. In order to export this model, I went over to bodies in the design tree, right-clicked on the body, and saved as mesh. I then verified .3mf file format was selected, hit OK, named my part as GT Lite Washer Circle, and hit save. Next, I double-clicked on the last extrude I made on the bottom left, so that I could select a portion of the water drop feature. I then repeated the process to save as mesh, but this time instead of saving it as circle, I saved it as drop. Next, I opened up Prusa Slicer and clicked on the import file button on the top left. I then selected the two files that we just saved. At first, both models were stacked on top of each other, so I clicked on move on the left, then clicked on the hide icon for the drop part. That way I could move the models apart from each other. Next, I selected the part that has the water drop feature and clicked on the place on face button on the left. I then rotated the part so that I could select the face that's opposite to the peak of the water drop. For my settings on the right, I wanted to print with a bead diameter of 0.2mm using PETG filament, and I made sure that the 0.4mm nozzle that's on the Prusa printer that I'm using was selected. And lastly, I increased the infill percentage to 80 because this is basically a washer and I wanted it to take the force of the tightening knob. Let me know down in the comments if you would like me to make another video where I go more into detail on these settings. With all of that selected, I clicked on Slice Now on the bottom right. Slicing the model builds instructions for the 3D printer. You can see each individual layer and each color has a different meaning. The orange is the outer shell, the red is the interior scaffolding and is basically the filler, and blue highlights areas where the filament will be suspended in midair. For example, in the standing up version that we made with the water drop feature, the blue filament will droop down a little bit, but this shouldn't cause any issues because I put a 0.6mm gap to the circle. The benefit to this design is that the teeth will be one continuous layer of filament, which will make them a lot stronger. In contrast, the teeth on the other version are made up of many little pieces of filament. These are more likely to break off because of the load direction that's put on these teeth when the steering wheel is tilted up or down. And now the last thing I had left to do was export the G-code to give to the 3D printer. This G-code could be used with most 3D printers, and if you don't own one, it's likely that there's a school or library near you that will allow you to 3D print using your own G-code. However, bad G-code can damage a 3D printer, so in some cases you may be asked to just provide the 3D modeling file, such as the .3mf file that I made. And here are the two parts that we just modeled. Starting with the water drop part, you can see there's some slight imperfections, but overall the print came out pretty clean. You can also see the drooping where there was some overhang. And lastly, you can see the continuous layers that make up the teeth. The circular version looks similar, but you can see the striations run across the part, including where the teeth are. As I held up both pieces to the black grooved part, I could see that the grooves of the teeth and the radius of the teeth did not line up very well. The edges especially seemed to flare up more. This made me think that there was something wrong with the diameter that I used. That's the end of part 1 of this series. In part 2, I'm going to show you the iterative steps that I took to solve this issue. I'll also show you how you can find parts that other people have made and uploaded online. And finally, I'll show you how my seat turned out when I installed the final version of my part. When I release part 2, I'll make sure to link it at the end of this video. If you found this or any of my other videos helpful, I'd like to ask you to please consider subscribing to my new channel. I just started posting videos at the beginning of May, and I have a goal to reach 100 subscribers by the end of the year. However, at the time of posting this video, I'm at 0 subscribers. If you have any questions or any other ideas you would like me to cover in this channel, please let me know in the comments. Until next time.